Okay, in this situation we have a random variable, it's normal, and it's got a mean of 50, standard deviation of 7. And we go get a standardized normal by taking a z-value, and our z-value equals some x minus the mean for x over the standard deviation for x. So we're going to go get the standard normal and then convert it to x. So if I click on this, I want the 67th percentile, so that's where 67% are contained in that value, at or below that value. So what we're looking for is a z-score whose area to the left is 67%. So it's kind of like this. Okay, so if we go look for the closest thing we can find to 0.67 in this table that they're providing us. So I'm looking at the areas to the left here. And 0.67, where are you? Here's 0.6772. There's exactly 0.67. That doesn't happen very often, but if I look at the z-score, it's 0.4, and up here for the second place, 0.44. Okay, so what we've discovered is that the z-value that represents the 67th percentile is 0.44 because its probability is equal to 0.67. So now we're going to take this and find the x value. Now if I were to solve this for x, I would multiply both sides by sigma, and then I would have to add the mean to both sides. Okay, and that isolates x. So really we get x equals sigma times z plus mu. Okay, and we know that sigma 7 and mu is 50. So we'll just take and convert this z-score here that matches 0.67 and be able to find the x value. So x is equal to 7 by sigma times the z that we found that matches that probability or that percentile. So 7 times 0.44 and plus the mean of 50. Okay, so we would get, punch that in the calculator real quick. $53.08. Okay, so this represents the 67th percentile. So this is the probability that x is so that would be the probability that x is less than or equal to or less than. Normal probability doesn't matter if you say less than or equal to. So in terms of x, that's what matches that percentile. Oops. Okay, so the 67th percentile, what we would put here would be 53 to 2 decimal places, so 53.08.